Can I hear at least one or two?
Yes.
Yes.
Good.
Yeah.
Good. All right. So we finished the define phase. We finished the measure phase. So what's the next one? Analyze. So it's the DMake process. It's define, measure, analyze, improve, control. So the next phase is the analyze phase. And again, this is a good map for the analysis. This is a good overview of where it will take you. Basically, you're just gonna go through these tools. In each phase, there are a number of tools, and these are the tools. What we're gonna do here in the analyze phase, we're going to analyze the process. How does the process actually work? How is it working? Now that we've defined the problem, we defined that there was a problem, we had a problem, we took the data, we measured it in the measure phase, and we've seen how we are performing against our customer specification. Now it's time to analyze the problem, if we decide that there is a problem. Because at the measure phase, you need to decide, is it a problem or is it not a problem? Now, if you decide that you're not performing very well, you have a bad performance, then you're going to the analyze phase. And basically, this is what you will do. You'll see how the process actually works. What does the existing process knowledge say? What do we know about the existing process? What does the data say, which is very important. We need to look at the data. We collected the data. Now we want to see what the data says. And how does the root causes affect the output, basically. So here, in each one of these, we're going to do process mapping. And Six Sigma, it goes, process mapping, it just goes one of, there's almost no Six Sigma project without a process map. There is a value stream map. There are other as well, which we probably will not touch all of them. But there is the 5 laws of lean. We need to understand there are 7 waste or 8 waste. So basically what we will do, we're just going to go through these tools. We're trying to understand these tools, and we're just going to complete each of these tools as applicable to our project. And we're just going to continue. And this is what analysis, this is what analyze phase is. So there are basically let's say two route maps in the analyze. There is the process door route map, and there is the data door route map. Let's start first with the process. And the process door route map is just basically mapping the real process as a common starting point. What you just want to take your process and you want to map it out. And these tools focus on analyzing when, where, and how the process might fail. Basically, where this is the process. Where can I be failing? Can I be failing at this point here? Can I be failing at this point here? And so on. So it's process mapping. Let's start with the process mapping. A process map is just basically a flow chart that actually it's basically representing your process. But the flow charts contained in a quality manual. If you go to quality manual, normally there is a process or a flow chart. But these flow charts and these manuals, they show you how the process should work. But in reality, does it really work the way it should work, or it doesn't? Then this is what you want. So what you do when you do process mapping, it's basically, it helps you understand how a process actually works. Not as per what is there in the manual, but what is actually happening. And the process mapping, it helps you identify what's a value add, what's a non-value add step, the decision points, redundant, repeated processes. You know, once you put your process map, you can see where are you repeating yourself and so on. Rework loops, and rework loops are basically the most common purpose for process mapping. You want to see, am I looping, going in a circle all the time? So you want to know. So this is a simple process map. And basically, let's go back to the service. You know, you're receiving an installation service. Somebody you install broadband services, for example, and now you receive an order. That's one step. Then you install the service, another step, and then the third step is you invoice your customer. And within each of these steps, there are sub-steps. And let's say now we are analyzing the installation step. So what do? We say, okay, that's the way it is being done. We plan the installation. We schedule the installation. We go and pick up the parts. We arrive on the site. We install the equipment. Once we install the equipment, we do the functional test, and that's the process basically. Once we're finished with these processes, then we go to the other big step. Here, what you want to do, you want to see all your rework loops. For example, you plan your installation, you schedule your installation, you go pick up the parts. But when you go to pick up the parts, you see that it's not in the stock, for example. So you say 10% of my time, I go to the store to pick up the part, and I don't find it there. So what I do, I go back to step 1 to plan the installation for another day. So that is a defect basically in your process, and that's need to be solved. And that's probably why it's taking you long to deliver what you committed yourself to your customer, because of a problem like this. Maybe when you arrive on the site, you find that you don't have access. Many places you need to have access. You can't just go to a facility, to a plan, and you say, I'm ready. Like what happened, you know, we're ordering a kitchen cabinet, and all of a sudden somebody knocking on the door and say, yes, I'm the kitchen installer, I want to. Maybe we're not ready for you. You need to tell us. You can't just knock on the door. For facility, for plant, facility, rigs, whatever, clinics, you can't just go, show up and say, I'm so if you don't have access, you'll go back, okay? So if you analyze your system and you say that, you see that 30% of your time, you're actually going back and doing another schedule. Maybe when you install the equipment, you find out that you installed the wrong part, and then you go back to planning. All of these, when you do a process map like this one, you are actually starting to analyze the problem. You're seeing why you're actually not meeting your customer specification. Whether this customer specification time, you're not meeting the time, or maybe you're not doing it the way right, or it's costing you too much, because at the end you're throwing parts, you're throwing many things. So the three things that we talked about. So the process map, basically it helps you identify value add and non-value add steps. Like all of these are non-value add steps. Going back is not a value adding step. Decision points, what do I need to do? Rework loops, redundant or repeated processes. So all of this, just by doing a process map, you can see the whole procedure from the beginning to the end, and looking at it, you can see where you could be. Just fixing these things can improve your process a lot. You know, just working in your stocks, working in your parts, working in, having access at the beginning. All of this would going to improve your process automatically. So, your variation will be much lower, and then your calculation, your process capability will be much better once you look into this. Another way of actually doing your process map is what's called the swim lane or cross-functional process map. It's the same steps, the same as we did. It's just, it's by the basically by the department. So customer services will receive the order, then we'll take it to the technical service to install, to plan the installation, then maybe come back to customer services just to show you who is basically responsible. So this is another way of actually doing your process map, and sometimes it helps you where most of your problems are. Is it within this department, and so on and so forth. Again, it helps you identify value stream within the process. The process map, it documents standard work, and it focus, basically the main focus is on eliminating non-value add. It will be very clear. Some, you know, once you do the process, you say, we're doing this step, then we do this step. And then once you challenge it, then you say, okay, is this step really a value add? Should we get rid of it? Is it important? How do we improve it? And so on and so on and so forth. Another map is called the value stream map, which is, it's a process map, but with more information to it. So basically, it contains maybe measurement of the time for each steps. Sometimes there are special symbols for it and so on. But it's advanced basically process map, and that's what the value stream map. Yes. All right. Process map or value stream map, they both can be current or as is, can be theoretical, like you say, well, we think this is what it is according to the manual, but most the as is more important, or it can be the desired one. You say, okay, this is not what the process map is. This is not what's in the manual, the theoretical one, but this is the desired one. So it can be either one. It can be current or as is. It can be theoretical or it can be desired. There is the value add chart. A value add chart basically helps you compare the balance of time across processes. And let's say you have this process, and with these steps, and let's say that this step is being handled by me, and let's say this is being handled by Dr. Fayyaz, let's say this is being handled by Dr. Hawra, and so on. You can see that there is a bottleneck. The bottleneck is probably this step here. So focusing in a step like this step, no matter how much you improve it, is not going to improve the process, because this is where the bottleneck is. He's taking a long time here. So here, this step and this step is taking a long time. So we want to analyze this time, and we compare this according to the takt time. And the takt time is how much production we are expected to be completing. How much time? You know, we have a product. Our process need to deliver one product, let's say every half an hour. Otherwise, we're going to. So if this guy is taking more than half an hour, so no matter how much improvement we do to these, then we're not going to, you know, it's not going to work. So this is our bottleneck, and maybe this is what we need to be improving most. Then we come to the next one and so on. But this helps you. And instead of trying to improve every step, going to each step and trying to improve it, sometimes your time, your effort, your money is better invested in something that is creating a bottleneck than something that's not creating a bottleneck. So this is important. Of course, there are value adding, there are non-value adding, and there is a business value adding. So there are activities that are business value adding. So what you want to do, you want to get rid, if you can get rid actually of all the non-value adding, you can bring the process back into business. Just by looking at the process, the step of the process, just take the normally we take yellow stickers and we write all the steps and we try to look at them. We take the time for each one, how much it takes, and we try to analyze it and see which one, because we are now in the analyze phase, We want to see which one we are going to start analyzing or analyze first. Principles of Lean Six Sigma. The principle is you make your process a flow without stoppages or cues. You need to have this mentality when you're going into the analyze phase. As much as possible, you want your process to flow without stoppages. Because once you stop, once you have a cue, then it's going to be a long work in the process and so on. So you need to. Another principle is continuous improvement of processes by everyone. Everyone need to chip in. This is the mentality that you need to do when you are actually in the analyze phase. Identify and understand the value of your product or your service. Where does my product add value? Most important, very, very important, and almost probably no exam is without a question like this. The purpose is to decrease the variation. You need decrease variation, especially in the delivery of your product. This is our service. Just you don't want somebody too big, somebody too small, or somebody taking too long, somebody taking too short. Somebody, you need to make them consistent. The more consistent they are, as we've seen before, when we calculated our sigma levels and so on, the less variation you have, the more you will actually be able to meet your customer demands. And it can be used basically. Some people think that Six Sigma and Lean is only for manufacturing. It's not true. You can actually use it for services as well and for other things. Just any process that you have, you can use these concepts. Even processes in your house. If you wanna just measure, you're always late doing something. You're not meeting a certain target. You could use these tools. How much is worth it? How much is not worth it? It's another story. Lean versus Six Sigma. Both can be used for improvement in both service and manufacturing, and their methods, tools, and techniques, they complement each other. They do not actually conflict each other. They are for the same purpose. Okay. There are 5 laws of Lean. The first law of Lean is the law of the market. Very important to understand this when you're actually analyzing your processes. The law of the market is like this. Quality characteristics can be defined by the customer only. It's the customer who defines what he wants. It's not you who define what the customer wants. So go back to your customer and understand the voice of your customer and respond to the voice of customer, because this is what he is willing to pay for. Law number 2 is the law of flexibility, because inflexible processes will hinder the flow. So if a production line is inflexible, it will be difficult to change a product between products. For example, you're producing something, now you want to switch, you want to produce something else. If it's not flexible, the more flexible it is, the better it is. Law number 3 is the law of focus. And everybody almost hear of the 80-20 rules. So 80% of the delays in a process are caused by 20% of the activities. So you want to focus on these 20% of the activities that is causing you 80% of the total delay. Law number 4 is the law of velocity, also known as, AKA means also known as little law. And this is what it is. The more work in a process, the longer its lead time will be. That's just the way it is. Some people, when they go to a restaurant and see it is very busy, they think it is for sure successful place. Not necessarily, because you don't want a lot of work in the process. WIP means work in progress or work in process. The more work you have in your table, the lower the efficiency of your process. It is better to just whatever you get, you finish. So if your process is like this, that's better. Law number 5, the law of complexity and cost. Unnecessary product complexity should always be challenged. Some people, they go too fancy in what they do, and sometimes the customer is not willing to pay for this. So if anything that you see is very, very complex, go and challenge it. Can we make it simpler? These are all very good one. So that's in summary, the 5 laws in summary. Read them later, but that's what they are. A very important concept when you're doing the analysis, you want to look for the wastes in your process. And in Lean, they identified 7 categories of waste. Now they became 8. So no more you will see 7 wastes, you probably see the 8 wastes. But the traditional 7 wastes are: overproduction is a waste. If you're producing more than needed, then that's definitely a waste. You're just paying money for something that probably you'll not be using. Waiting, and that's normally waiting is you wait for until the completion of a large batch of a previous steps. You're staying and you're waiting for somebody else in the previous step to give you his product to be able to process it. If you're in a line, then you're waiting for someone else. This is a lot of waste, and you see this a lot. You go almost in any process. You see somebody is idle, and you say, "Why are you idle?" He's just waiting for someone to finish. So this is, and all of these need to be challenged and eliminated. This is how you improve your process. So you just look. This is how you analyze it. You look at these things basically. You try. Transporting, unnecessary movement of material, taking it from this place to another place. Can we do something about it? This is all part of the analysis. Over processing, which is complexity. If your customer requires this feature, this much features, don't over process it. Maybe it's a waste. Maybe he just doesn't care, if you add this to it or you don't add this to it. So you always want to look at this. Unnecessary inventory, and inventory is a big cost, because inventory, you get losses in inventory, the storage, the place, the rental, the guard, the whatever, all of these. If you don't need a lot of inventory, don't just come and bring a big thing and put big pile of inventory. You need to challenge this. Unnecessary motion. And the most important one is the defects, errors, because error is the waste. You do an error, you do something defective, you write an invoice and the invoice is wrong. Or I don't know, you fix somebody's teeth and then whatever you did is not really the right thing, and you have to redo it again. So this is all defects, and it has to be eliminated. And you just need to look at it. You need to look at what inputs do you need and what are the outputs, and you just analyze it and see. But these are things that you need to be looking at. Some new waste that's been introduced to the traditional 8 waste basically is wasted human potential. That is a waste. Somebody very smart and you have a lot of potential, and that's what's happening in many places. There are young people maybe with a lot of knowledge, a lot of energy, a lot of potential. Maybe they're not utilized, so you wanna utilize them. Or older people like myself, maybe wasted energy as well. So look, are you wasting energy? Pollution, wasted space. sometimes is something that you be looking at. Waste from service perspectives, delay in provision, that's a waste. Incorrect inventory leading to customer to move to another provider. You're losing your customer basically. Duplication, data entry, you're doing the data entry and it's wrong data entry, you're gonna have to redo it again. You know, all of these are waste. And then when we go to the improve, we're going to discuss some ways and how to actually improve this situation. And most of it by standardization, writing a good procedure, communicating the procedure, training people on that procedure. All of this will help reduce all these problems, all these wastes, and will create consistency basically in the delivery of your product or your service. So this is the 8 waste. Traditionally 7 waste. Now they are 8 wastes, and they actually can be summarized as downtime. And what it means D stands for defects, which is rework, correction, rejects, scraps. So this is a waste anytime you see defects. O is for overproduction. You're producing more than what's needed. W is waiting, as we discussed. N is non-essential processing or over-processing. You're processing something, adding more features than it should be. Transport, inventory, as we said, and motion, and basically employee and use creativity or ideas or skills. Wasted skills, basically. Very good. While we're talking about waste, there are also 3 definitions, like Japanese definition. Because Lean Six Sigmas, you know, started in Japan, Lean specifically, so a lot of these words are actually coming from Japanese. But you have the Moda, the Mori, and the Mora. And they're all wastes, but they are different in concepts. Mori basically means overburdened. Like this truck here, maybe it shouldn't be carrying 6 tons. So if you overburden it, at the end, you're going to waste your vehicle. You know, you're going to lose it. So that is one waste. So it's like overburden, and that's what Mori means. Mora is unevenness. Like if you have 6 and you're putting 4 in one, and you're putting 2 in another one, and that happens a lot. You know, you have people working for you, and you see that most of the load are in one person, because he's a fast horse, and others maybe they're sitting and unutilized. So this is called mora, or unevenness, fluctuation, variation. You know, and we need to reduce the variation. So it is a variation. And moda is the waste here. So here, this car can actually carry 3, and we're only loading it with 2 tons. And instead of needing only 2, like in this case here, now we're needing more than 2, so we're needing 3 instead. So this is the meaning of Mori, Mora, and Moda. And this one here, the last one, basically no Mori, no Mora, and no Moda. So these are concepts that is you'll hear a lot in Lean Six Sigma, but I found this illustration is the best way to illustrate Moda, Mori, and Mora. Spaghetti diagrams. And I think in many processes, it's a lot of spaghetti diagrams. You know, you come in here and then you start at this maybe, and then they'll send you to this room, and then when you finish, take you to this room, and then when you finish this step, you go to this room. And as it looks like, it's really a spaghetti in a way, okay? So your processes, if you see spaghetti in your processes, try to make them not a spaghetti, you know, just make the process flow, even geographically, you know, in your space, flow from place. And I've seen many processes, you know, like even in the government. I remember in the government, before you go to finish anything that you have, somebody will send you to this building, and then they will send you to another building over there, and come and get the signature with the boss here, and then go to the bank and pay there, and it's just like, it is a spaghetti in a way. But nowadays, and with the help also of online and computer and applications and so on, things are becoming more streamlined. So that's, you know, anytime you see a spaghetti in your process, is something that you want to challenge. So after you look at your process, now you have a good idea about, you know, what's happening. Now it's brainstorming time, and I think in Arabic they call it al-asf al-dhihni or something like that. But it's a brainstorming. Brainstorming can be used to consider a whole range of possible root causes. This is the purpose of the analyze phase, is to actually identify the possible root causes to a type of failure. So when you're running a brainstorming, and I'm sure many people have already, you know, familiar with this, you know, participants can give turns, or it can be free for all format. Or alternatively, it can be done over time by placing maybe a fishbone diagram. And in the fishbone diagram, everybody will come and this is what a fishbone diagram is. And it's called fishbone because it does look like a fish bone. And basically, normally the problems are categorized into categories. There are people problem, there are machinery, equipment, tools problem, there's measurement method problem, environment, material, and basically you can hang something in, you know, in the wall, and when somebody think of something, you can actually, you know, fill it up. Or you could just, during the brainstorming, you sit down and you try to list all possible causes that could be happening. For example, leading to a low fuel efficiency. Why is this equipment is low fuel efficiency? Is it car usage? Is it a driving style? And within the driving style, is it low speed? Is it high speed? Within car usage, is it passenger? Is it heavy load? And so on. So is it the weather problem? So you try to put all the possible root causes of a problem, you put them in a fishbone. This fishbone tool will help you brainstorm basically, and bring all the ideas that you have and put them. Fishbone is also called cause and effect. So if you're going for a green belt, for a black belt, for you need to know that fishbone is also called cause and effect, C&E, cause and effect, and also called Ishikawa. That's the scientist who actually came up with this. He came up with this, and he said most of your problems will be coming either from sometimes 5M or 6 main categories or 7 main categories. They cannot go outside this, but that's Mr. Ishikawa, and this diagram is called after his name, so Ishikawa. So this is a cause and effect diagram, but there is also something called cause and effect matrix. Cause and effect matrix is different than cause and effect diagram. Cause and effect matrix is basically, now you're taking all the potential inputs of each step, and you're trying to see how much they weigh, because you can't really boil the ocean. You want to identify the causes that are most with most effects basically to handle them. So having identify inputs and outputs, now cause and effect can be utilized to identify which one is more important than the other. And the way to do it, to do a cause and effect matrix, is you start basically with here, number one, and basically this is your process output. What do you want your output to produce? So, for example, you want a correct product, you want effect packaging, you want on-time delivery, and you want correct invoice. And all of this, all of this comes from where? Comes from the critical to quality tree that we said. So this is what our customer wants. And number two, you give weight for each one, because they're not all equally important. So for correct product, maybe you want to give a 10. For effective packaging, yes, it's important, but maybe it's not as important, so you're giving it 8, and so on. And time delivery, maybe for this particular customer, it's only a 5. Correct invoice, maybe 7, and so on. So you do 1, and then you do 2, then 3, which is you go through your process steps for each one, like receive an order, pick order, package, ship. For each one, you go and see the inputs. What inputs do you need to complete this process steps? So that now you're actually looking into the inputs because you want to improve, because the output depends on the input. So, okay, what do I need? I need the product codes, I need product quantities, I need delivery system. So all of these are important. So when I do the improvement, I know which one to focus on more. So I fill up these. And now, what I do is I do number 4, which is the relationship between this and this output, between this input and the output. It's a product code, for example, is very highly correlated with the correct product. If you don't have a product code, if you don't enter as an input the right product code, you will not get the correct product. So this correlation number is a 10 here. Maybe the product code with the packaging, it has nothing to do with effective packaging, so we're only giving it 1 here because it's not really related to it. But once you complete all these numbers and all these correlation number to these here, then what you do, you go and multiply this number by this number, and you add to it this number times this number to get a total score here. So 10 times 10 is 100, plus 8, plus 20, that's 128, plus 49, then that's a total of 177. Now, after you do all of this, number 5, what you want to do, you want to see which of these inputs is more important. So you go the highest score, like 177, 157, 115. So you say, if I just focus, that's what they analyze, the result of the analyze now. You say, if I just focus in getting a good product code, no mistakes, I'm going to write a procedure, I'm going to put a good standard, I'm going to, and then we'll look at the improvement later, okay? If I improve in these, then I'm going to improve my process a big time. And that's the power here of a cause and effect matrix. And again, this works for anything. Whether you're producing coffee, or you're producing students' knowledge, or you're making teeth, or for Dr. Hawra case, she's a pharmacist. So, you know, making medicine or whatever, these are all very important. They just use the same tool basically to get to this. Another tool here, and these are all collection of tools. Sometimes maybe you don't want to use all of these tools, but they're all good tools. You know, if you can finish them all, they help you. This helps you analyze the location of a failure sometimes. Let's say this is an invoice. If this is an invoice, you say, where are most of my problems are? So each time you have a problem, you just put a spot here. And say, I had one time, I had a problem with the billing address. I had what, 1, 2, 3, 7 times I have a delivery address problem. Then I need to look at what's happening, what's going on there. Why do I always get delivery address problem? I just need to look at it sometimes and see, you know, how this sub process is going and try to fix it. Then I see that in the totals, and you know, there are a lot of mistakes here. So this helps you, it gives you a quick look. And instead of putting it in something like this, it's difficult to see. Here, you're putting it all in a visual manner, and you can see where most of your problems are. And this way will help you analyze and find out where most of your problems are.
Please.
Yes.
Can I ask one question, please?
Yes, please. Who is this, please?
This is Mofak. If we go back to the cause and effect matrix,
yeah,
please. Here we give a weight, and step number 2, we give a weight for each process, 10, 8, 5, and 7, right? And yeah, down we are filling the schedule on step number 4. I noticed some points evaluated more than the weight that we give already. And for example, here on point number 10 and 11, 10 we give a 9. On step number 2, we give 9 evaluation, right? 9 points.
So you're talking about 10. You mean here 10? You mean 10. This one here? This one?
Yes. 10. Process number 2, we give 9, for example.
9. This number here. Okay.
Yes. 9. How we give 9 and it's more than the 8? I don't know if my question is right or not.
No, yeah, thank you for this question, thank you. 8 is the importance. How important is effective packaging to our customer? Does my customer is a fancy person, he really cares about packaging more than the content itself or not? In this case, you know, we said, okay, our customer is a practical person. Yes, he likes good packaging, so we gave it 8. But he really cares about the correct product better than the packaging. He's not there to take a photo with it. He wants a good product. So this is the importance here. Now, this number 9 here, what it means is that how is boxes related to packaging, to effective packaging? 9 means it's highly correlated. You know, if you don't have the right boxes, you will not have good packaging. That's what it means. Okay.
So 9 out of 10.
And all of them are out of 10.
Okay.
These numbers are out of 10. So how is boxes related to effective packaging? It is very related. So you give it a 9 or a 10 or whatever. If it's not related, then you give it, you know, you give it a low number. That's what it means. Is this clear?
Great. Thank you very much. Yes. Thank you.
You're welcome. Okay. Now another thing that's is the FMEA. It's you see it a lot, and it comes from reliability. Actually, you know, FMEA is highly used in reliability more than in Six Sigma. But FMEA stands for failure mode and effect analysis. And here in FMEA, basically you use subjective scores for the severity, the likelihood, and the detection. You have a failure mode. There are a number of failure modes that could be happening. Okay, so you want to look at each failure mode. You want to see the severity of this, and then the likelihood or the probability of it happening, and also another factor which is called the detection. Is it detectable or is it not detectable before it actually happens? So again, it's a score from 1 to 10. If it's extremely severe, if this failure mode is extremely severe, then you give it a score of 10. If it's not severe, you give it a score of 1. Again, for the likelihood, for extreme likely, if it's extremely likely, you give it 10, because this is what risk is. It's how likely something will happen, and if it happens, what's the severity of this? Plus another thing, which is the detection. Is it, can I detect the problem before it happens, or is it 10? So it's called about detection. If it's 10, if it's bad detectability, then you give it a 10. And if it's good detectability, because that means low risk, because you can see it, then you give it 1. And if you multiply these numbers together, you get an RPN score. It's called risk priority number score for each one of them. And let me give you this example. It's a real example, actually, that we did. This is a lube oil tank. And the lube oil tank, basically take the oil and send it to the pump here, because the pump needs to be lubricated. But if we look at the tank only, the level in the tank has to be high enough in the tank. Otherwise, just like your oil in your car, if it's low oil in the tank, then it could create a lot of problems. The way to see the oil, how much level there is in it, there is something called the sight glass in the tank. Basically, a sight glass is this is an open pipe, so whatever level here, you will see it in the glass here. Now, there were a number of problems with the pump. It was tripping because of low pressure, because of low oil, and that created failure actually to our bearing, and some failures can be very expensive, of course. So now we want to generate an FMEA for this process, but let's look at this. So the low level in the lube oil tank, as we said, the operator was misled by buildup. See, this glass, because it's oil and hot and temperature, sometimes you cannot see through it. So when the operator was asked, why are you not checking the oil in the tank? He said, well, I can't see it. It's all dirty with oil, and with the sun, I couldn't see it. So he was misled by the reading. And the PM technician, when he was asked, why did you not change it? You're supposed to be changing it every year. They said, oh, to change it, you're gonna need to empty the whole tank, and because you can't fix it like this. You really have to empty the whole thing. And emptying it, that means like a downtime of the equipment and so on. And the operator, they told him there is a leaking here. So it's very clear that the tank is going low because it's leaking. Why didn't you tell? I said, oh, it's a minor leak. And so all of these were problems. Now, if we want to do an FMA analysis to this, and I'm sorry, I know that all of you are not mechanical engineers or something, but this is something that everybody can understand anyway. So basically, these are the failure modes. You take each failure mode and you try to calculate an RPN number for it. And then you take the one with the highest RPN number and you try to deal with them. So, undetectable sight glass. So maybe the severity, how much severity there is. Oh, this is highly severe to the problem. What's the likelihood of it's happening? That's very likely. What's the detectability? The way it is now, it's not highly detectable. Okay, so you say, okay, so that's poor detectability. So you give it an 8. So you multiply 8 times 10 times 8, you get 640. So that's failure mode number 1. So this is a high number here, and you need to work on it. And a skilled operator, yes, this is severe if he's not skilled. So the severity is very high. So, overall, you just calculate risk priority numbers. And now what you need next to do is you try to come up with recommendations. You say, what if the site glass is not clean? Well, the recommendation here, for example, is site glass to clean it. So include it in the PM schedule and so on. I don't want to go into this because this is really for reliability engineers and so on. But at the end, you come up with recommendations, and based on these recommendations, like including it in the PM schedule, redesigning to detachable, you can actually put here a flange here and a flange here with a valve. So you close the valves, and you can take this, you can detach it and clean it without emptying the tank. And that's the biggest improvement actually here. But that's the way, you know, you need to be targeting where your failure modes, and you want to the most severe failure modes, and you try to fix them. So that's what FMEA is. So FMEA is a failure mode and effect analysis, and it's there to detect root causes and so on. So with this and the analyze now, we are finished. We said that there are two doors into the analyze. One is the process data door, and the other one is the data door. So we're finished with the process mapping door, and now we're going to go to the data door. And I think maybe it's time to stop for another maybe 10 minutes. Do you all agree? And then we come back to this.